Good morning, guys. Happy Thursday. Today we're going to continue looking at density. So before I go on, I would like to just show you that this is the worksheet. It's called Density Practice. And this is what we're going to be filling out today during class. So today's do now. In your own words, describe or explain why the units used for density are grams per milliliter or grams per centimeter cubed. So take a moment to write out your do now, and then we will talk about it. So density uses grams per milliliter or grams per centimeter cubed because it requires both the volume and mass values. Therefore, it must incorporate both in the final density value. So remember, density equals mass divided by volume. So we're using the mass unit, which is grams, and then volume, which if you have a liquid is milliliters, and if you have a solid is centimeters cubed. So that's why it has both. So let's practice. So I'm going to get out of here and go here. That way you can see what I'm writing. Okay. So what is the density of the object below? So first, we know that we have our mass, which is 39.0 grams, but we do not have our volume. So we have to first calculate volume. So remember, volume equals length times width times height. So when I multiply my length, which is 5.0, times my width, which is 3, times my height, which is 4, I get 60.0 centimeters cubed. So now I can use that value to plug into my density. So we know that D equals M over V. Density, our mass is 39.0 grams over our volume that we just calculated, which is 60.0 centimeters cubed. So when I do the math, when I divide 39 divided by 60, I get 0.65. Now we always want it to the nearest tenth. So because this is a 5, I'm going to round up. So our final density is 0.7 grams per centimeter cubed. I'm going to put it in a box in a different color. That way we can see it. So 0.7 grams per centimeter cubed. So how would this object look in a cup of water? So we said that the density was 0.7. And if you remember from Tuesday, when we draw it in a cup, we always want to multiply by 100 to turn it to a percent. So if I multiply by 100, this becomes, sorry guys. Okay, this becomes 70%. So the 70 we know is going to be below the water line. So when I draw my object, I want to put most of the object below. And then when we figure out the rest, so obviously the percent is part of a whole. So if we take 100% minus our 70%, we get 30%. So 30% is what is above the water line. All right, so what you're going to do for class today is you are going to find the missing value for the objects below on your worksheet. So you're going to, if we were in regular school, you'd be drawing what each object would look like in a beaker of water, but I am just going to ask that you type in the percentages for above and below the water line based on your calculation. So what I mean by that is if we go back to our worksheet, I have here percent above the water line and percent below the water line. So you're going to calculate the density of the rock. So you're going to take your 39 divided by your 22.7. And then once you turn that into a percent, you're going to tell me what percent is above the water line and what percent is below the water line. Remember, the density that you calculate is always the percent below. So in the example that we just did, our density was 0.7, and then when we calculated it was 70%, that value is below the water line. So whatever your density is below the water line. So take a couple moments to complete the worksheet, and then come back and we can talk about the wrap up. So can you use density alone to determine the material of a given object? What do we think? On Tuesday, we talked about how density does not change and that is a constant, but can you use density alone to determine what material is in front of you? Take a moment to think about it and then we can talk about it. So in theory, you could use density. However, in the universe, there are so many different materials that exist that have the same exact density. So you can't use density alone to identify material. So while it sounds good and maybe we might be able to, unfortunately, because there are so many different materials that exist, we cannot use just density alone. We would have to use other properties as well. All right, guys, that's it for today. I will post an assignment for tomorrow for Friday, and I will see you tomorrow. Bye.